Okay, so this is borrowed from your Do Now. If you didn't get a chance to jot it down, I guess you could do so quickly. So we're going to start to talk about something called a pSeries. Okay, it's one in which you can see there's an infinite series, and it's 1 over n to a power of p. P is some number, okay? Now, if p is equal to 1, it's called a harmonic series, okay? And you may be looking at the word harmonic and thinking of a harmonica or something that is in harmony, like when you're singing. So that has to do with the terms corresponding to the nodes on a vibrating string like a guitar. And it produces what's called a fundamental frequency. That fundamental frequency is the lowest note or pitch that we hear when a string is plucked. Okay, so half produces the harmonic that is twice the fundamental frequency, and a third produces the frequency. Okay, so it starts at 1, and then it goes to 1/2, okay, and 1/3, and so on if p is equal to 1. Okay, makes sense. Hopefully it makes sense. So 3 would be that it's a third, so produces a frequency that's 3 times the fundamental frequency. And, well, this part is what you guys need to make sense of rather than the whole music background. But it's interesting if you want to have that association between mathematics and music. It's right there. Okay, so the pSeries is convergent if p is greater than 1 and divergent if p is between 0 and 1 or equals 1. Okay, so that harmonic series is actually one that diverges because p equals 1. Okay, so if you didn't have that copied still, then make sure you pause the video and go back. We're going to do some examples. So we have example 1 and example 2. So in number 1, we actually have to rewrite this, okay? So although that may be annoying, it's pretty cool that we get this practice to do so. Okay, so if you take a look, it is a series, okay? And since we see an ellipses at the end, it's an infinite one. So we have to figure out a sub n. Well, the numerator in each of these fractions is 1. And the denominator is a number that is raised to the 1/3 power, okay? But that number seems to be squared. Like this would be the cubic root of 1 in the denominator, and then it's the cubic root of 4, 9, 16, 25. So we probably say n squared, where n is equal to 1. So you could try it out and make sure that this is the terms in your sequence. And it does turn out to be that way. So now what we're going to do is take a look at this just by combining power raised to a power 2 times 1/3. And that gives us that p is 2/3. All right, well, since 2/3 is between 0 and 1, this series diverges. Okay, so I kind of went up with all of my work here to make my conclusion, okay, but we just did that test. So let's take a look at number 2, and maybe we'll have some answer that's not divergent. Maybe we do. It looks a little bit different than the other one, so let's do that one. Okay, so this is another one that I've seen a lot in textbooks and workbooks and AP questions. All right, so the first thing we're going to do is rewrite our sum. And the way in which we're going to do that is to say that it's like n to the first over n pi, to the power of pi. So if you have the same base, you subtract the exponents, you get 1 minus pi. So these are equivalent. Okay? Now, you may be thinking to yourself, this doesn't look anything like our pSeries that you just described. There's no 1 in the numerator. Well, if I factor out, and I'm going to do this step by step, you don't need to do this step by step at all. If I factor out a 1 over n, that leaves 1 in the numerator. Well, I'm going to do the same thing with the denominator. Okay? And what happens is that I'm dividing by n to the first. That's supposed to be a pi there. There we go. So if you take a look at this, okay, n to the first over n to the first is 1. And so we have 1 over, and I'm just going to use that power rule. Same base, subtract the exponents. Now for some students, they're just like, oh, this is easy. It's the same thing as just negating this, and we get that. So you don't need to do this step by step, but I want to explain that just in case you didn't see it. Okay, so you got to work it out so that, hey, we do have something like 1 over n to a power. That power is p, and p is pi minus 1. Okay, well, pi minus 1, pi being about 3.14, it's going to give us about 2.14. Well, that happens to be greater than 1. Therefore, this series converges. Yay! All right, we don't know its sum, but we know it converges. All right, so I hope you're happy with it as well as I am, as much as I am. And good luck in the practice.